Okay, hi folks. As you can see, I'm out sick today. So a couple things. First thing, obviously, you've navigated to the section 4.4 tab. So you found this video, which is great. This link is going to become the video, so that's probably where you clicked on it. Just make sure you check this this PDF here. That has the homework key on it, so make sure you check your answers. If you have any questions, just kind of ask around with neighbors and see where you did. I totally understand. I'm going to click on it real quick. This one, rough, 4x4, ouch. So just kind of ask around. I'll explain it tomorrow if we need it. Remember, tomorrow is a late start day, so it's shortened period, so I'll have some time to kind of catch up. But yeah, that 4x4 is a little rough, but that's all in the PDF, and you can access it through that link right there. Notice that here's the homework, so as soon as you're done watching the video, you can start on your homework. You can work together just as long as the sub says it's all right. All right, so I just kind of want to run through the, look, there's my Algebra 1 stuff, slope, look at that. I just kind of want to run through the PDF of today's notes. I have it solved here for you, so whenever you need to pause and copy some stuff down, that is completely fine with me. Just make sure you pause and jot down whatever you need to. So today's section 4.4 is determinants and Cramer's rule. Again, with all this matrices stuff, not something not something necessarily difficult, just different. Okay. Now, determinants are always for square matrices. Every square matrix has an associated value called its determinant. It's just a number, basically. A number is the determinant. And we write it, when we say we want to use the determinant, we just replace those brackets with vertical lines. So if I say I want to use the determinant of this matrix down here, I just basically take those brackets off and put it straight lines. Now, how do we solve the determinant? It's the difference of the products of the diagonals. Right there. It's the difference of the product of the diagonals. So that means I'm going to be taking 1 times 4 minus 2 times 3. Now, work with the main diagonal first. This top left to bottom right diagonal is called the main diagonal. You work with that diagonal first, and then you subtract away the other diagonal. So 1 times 4 is 4, minus 3 times 2 is 6. So the determinant of this matrix is -2. Yes, it's that simple. Don't associate this with any sort of absolute value thing. Okay, so here's a couple determinants for you. So the determinant of this matrix, 1 times 8, 8, 5 times 4, 20. So notice here that the notation, you would write DET, the determinant of that matrix, which is also equal to the straight line version of that. So it looks like a big absolute value, but again, not really anything to do with an absolute value. 1 times 8, 5 times 4, 1 times 8 is 8, 5 times 4 is 20, 8 minus 20 is -12. So the determinant of this matrix is -12. The determinant of this matrix, 0.2 times 5 is 1, 30 times -0.3 is a -9. Just watch out here for sometimes with these double negatives, 1 minus a -9 would actually turn out to be a +10. Okay, now, how is this useful? It's useful because you can actually solve a 2x2 system using determinants. So along with substitution and elimination, now we have this thing called Cramer's rule. So Cramer's rule is down here. What you have now, all of these systems must be in standard form. AX plus BY equals C. AX plus BY equals C. Now, you have this thing called a coefficient matrix, just basically taking your coefficients off of the x and y values and using your coefficients as a matrix. The determinant of that matrix is used inside Cramer's rule. Now, look, there's that big D, big D. That is the determinant of the coefficient matrix. Those are your denominators there. Now, how do you find the numerators? Well, what you're going to do is you're going to take your values, your C values, and replace them with whatever variable you're trying to find. So if I'm trying to find my x value, x equals, I'm going to replace the c's with my a's. So I'm going to say, okay, c's are going in for a's here. Leave the b's, find the determinant, divide it by big D. Same thing for the y values. Okay, I'm trying to find my y's. That means the b's go away. I replace those c's with the b's, find the determinant on top, divide it by big D. That gives you your x value and your y value. So that gives you your coordinate on where these two lines are going to cross. So let me show you an example of how this works. Again, pause where you need to. So here's my system here, already set up for me in standard form. 2x plus y is equal to 10. 3x minus 2y is equal to 8. Big D, 2, 3, 1, negative 2. Right? There's my determinant of, there's my big D, my coefficient matrix. Negative 4 minus 3 is negative 7. So those are my denominators there. You put them right down here. So x, I'm going to replace my x values with this 10 and this 8. So 10 goes on top, 8 goes on bottom, and then 1 and negative 2. Determinant here, negative 20 minus 8, negative 28, divided by negative 7, x equals 4. So there's my x coordinate. Same thing for my y coordinate. But now I just replace the 10 and the 8 in place of the 1 and the negative 2. Because I'm finding my y's, you replace the y coefficients with these c values. So negative 14 divided by negative 7 is positive 2. 4 comma 2. There's the point where these two lines will cross. I would pause for a second and try this one down here. If you're following along with the PDF notes that I have in that link, this is blank, so you can kind of work with it there. I'll pause and let you guys try to work that one, and then I'm just going to show this answer. Okay, so here's my answer there. Negative 4 comma negative 7. Your big D turns out to be positive 1. Watch out again for that double negative. Negative 1 minus a negative 2 ends up being positive 1. So therefore, the denominators are both positive 1. Here's my cat. 3 times negative 1 is negative 3. Minus 1 is negative 4. So negative 4 is my x. Same thing here. And then for negative 7, so negative 7 is my y. There's my coordinate. Now, lastly, sometimes that's when life's nice, right? When it's just going to cross once. Here are the rules and when you can tell when your determinant is going to be, when it is not 0, it's just going to cross once. If the determinant, if big D comes out to be 0, those lines are, lying right on top of each other. An infinite solution. If D is 0 and at least one numerator is also 0, I meant to say that, then it's on the line. Those two lines are going to be the same. If D is equal to 0 and neither numerator determinant is 0, then it's inconsistent. The lines are parallel. So for example, down here, I have my big D, 3, 15, 5, negative 6. Oh, look at that. Add the 9 over, subtract the 15. Got to be in standard form down here. 3, 9, negative 2, negative 6. Big D turns out to be 0, so something weird is happening. You find the numerator determinants. Look at this first numerator determinant. Negative 5 times negative 6 is 30. Negative 15 times negative 2 is 30. My numerator determinant is 0. If either of the numerator determinants are 0, then this is infinitely many solutions. Basically, the lines are lying right on top of one another, so there's infinite solutions. If neither of these numerator determinants came out to be 0, but big D was still 0, then it would be an inconsistent system. The lines would be parallel. So I hope this kind of cleared some stuff up for you. I would, again, if something did not make sense, I would go to the online book website. These example videos are really good. So if you need help, check there too. Okay. I hope everything is good at school. I'll see you tomorrow.